Okay, we have here today another integral from the MIT Integration Bee 2013, problem 23. We have the integral of secant to the fifth x, tan cubed x, dx. Okay, now this is the kind of integral you see a lot in calculus class. It's like a very common situation where we're dealing with secant and tangent. They work well together. And this is going to be the case when we have odd exponents. Now, oftentimes when you have an even exponent, you'll use one of these formulas over here to the right. Just this second one's just rearranging the first one, because then this gives us a nice way to deal with tangent squared or secant squared. But you'll notice when we have an odd exponent, it's never going to quite work out cleanly like this, so it doesn't really work that well for setting up our u substitution. So what I can do instead here is actually take a secant out here, take just one copy of secant out here and one copy of tangent out. So we'll write it towards the end of the integral. We'll just have secant x times tan x dx. Then this first one's now it's going to become secant to the fourth x, and this one's going to become just tan squared x. And now that we have even exponents over here, I can kind of use one of these formulas. So like we have tan squared here, and we have this formula for tan squared. So I can rewrite this for tan squared, I can rewrite this as secant squared x minus 1. So what that's going to allow me to do is everything over here to the left, everything we're going to have in terms of secant, and then we have the derivative of secant right here. So we're kind of setting up our u substitution. But before we get to a u substitution, let's actually distribute in the secant to the fourth here into this. So this is going to give me secant to the sixth x minus the second term is going to be just secant to the fourth x, and then we'll have all this stuff at the end. But now I can go ahead with the substitution. Again, our u value is going to be just secant x, and the derivative of secant x is just secant x tan x dx, which we have right here. So we'll go ahead with this. This piece here is just going to become u to the sixth. This one here becomes minus u to the fourth, and this is going to just be du. But now this is just power rule, so we'll go ahead and integrate. First term, it's going to be u to the seventh over 7, and the second term is going to become u to the fifth over 5. But our u value is just secant. So for my final solution, we're just going to have secant to the seventh x over 7 minus secant to the fifth x over 5. Add a plus c. Add a plus c on there, and that's it. Okay, there you have it, the secant times tangent problem with odd exponents. Thanks everyone for watching. Have a good day.